Good morning, both of you. So we are now into our second lesson on matrices, which will follow on directly from the lesson that I showed you on Monday, which was to do with finding the determinant of a 3 by 3 matrix. A quick recap. This is a 3 by 3 matrix. Each of these numbers in here is called an element. Each of those elements has something called a cofactor. To find the cofactor, for example, for the 2, you would cross out the row and column that contains the 2, and then find the determinant of the remaining elements. This would be this 2 by 2 matrix here. Having found that determinant, you then apply this matrix here. In other words, you change the sign of that value if required, according to this matrix, to find what are called the cofactors. Okay, so that one didn't change, that one did, that one didn't. It's top row, plus, minus, plus. You then multiply each of those cofactors by the actual original elements of the row, and that finds the determinant. What I said last time, really important to remember, is that that works regardless of the row or column that you choose to do it with. It actually says in the notes, if you read them, that you should try and choose a row or column that contains a 0, because that cuts down the amount of work that you have to do. So, for example, if I'd have chosen this column here, I would only have had to calculate 2 cofactors and not 3, because the 0, 1, although it has a cofactor, when you come to do the determinant a calculation, because you're going to be timesing by 0, that one's going to disappear. But I wouldn't get too worried about any of that. Now, here's a fun fact for you. This method for finding the determinant of a matrix works regardless of the size of the matrix. Remember, determinants are only for square matrices, okay? But we could use this method for a 2 by 2 or a 4 by 4 or a 5 by 5 matrix, which I think is quite exciting, really. Let me get a piece of paper to show you what I mean. I was going to move on to today's lesson, but I'll just quickly show you that. See if I can find a piece of paper somewhere. Here we are. Right, so take, for example, the generic 2 by 2 matrix A, B, C, D. Let's apply the same method for finding the determinant of a 3 by 3 matrix to this matrix here, a 2 by 2 matrix, the generic one that we know and love already. So, according to the method, I need to find the cofactors of each of the elements in a row or column. So let's pick the top row, and let's start with the A here. Cross out the row, cross out the column. Find the determinant of this here, which, because it's just a value, is the answer anyway. So the determinant of that is that. So remember, these are called the minors. So the minor for that one is D. And if I do the same for B here, the minor of that one is C. Okay, then I have to apply my special matrix here to decide what the actual cofactors are. So the cofactors for this one here is still going to be D because it's a plus, and the cofactor for this one here is going to be minus C. So I end up with D and minus C. Then, if you recall from the 3 by 3 case, to find the determinant, what you have to do is multiply the original element by its cofactor. So I times the A by the D, and then I've got to add to that what I get when I times the B by the minus C. And joy of joys, what do I end up with? Not only our original formula for finding the determinant of a 2 by 2 matrix. Wow. But it gets better, because This works for a 4x4 matrix. I can't believe I'm going to write one out, but I'm not going to do this. I've got all day. But feel free, if you've got a bit of spare time, really want a challenge, to try. You really would have to be sad to do this. To try it on there. It actually works on there as well. Okay, so to find the determinant of that, you would have to, for each of the 4 numbers in the top row, if you like, I'll just do it for the 4, you would have to cross out the row and column, find the determinant of the resulting matrix, which, oh my goodness, is a 3x3 matrix. You'd have to use all the methods required to find the determinant of a 3x3 matrix for that one. You then apply the pattern matrix, plus, minus, plus, minus, minus, plus, minus, plus, etc., etc. Okay, to find the cofactors, 4 cofactors for the 4 elements of the row of ones on the top, multiply them all together, and you will find the determinant of a 4x4 matrix. It works for a 5x5 as well, and a 6x6. But my goodness, can you imagine the amount of work required to find the answers if you were doing them by hand? I'll leave you to think about that. Anyway, on to today's lesson, which is finding the inverse of a 3x3 matrix. Exciting stuff. Okay, so what I decided to do, I'll take you through an example in a minute, but what I decided to do this was to just tell you how to find the inverse of a 3x3 matrix in words, and then we're actually going to do it. So, in words, to find the inverse of a 3x3 matrix, although what I'm about to say applies to any square matrix, any n by n matrix where n is an integer, this is what you do. Let's see if I can say this correctly. You find the transpose of the matrix of cofactors and multiply it by the reciprocal of the determinant. I'll say that one more time. You find the transpose of the matrix of cofactors and you multiply that by the reciprocal of the determinant. Whoa, what does all that mean then? Well, let's do it and see. So I'm just going to do the example from the notes. Okay, so we are going to find the inverse of the following matrix. This is the one from the notes. So we're going to find the inverse of this matrix if it exists. It does exist, or I wouldn't be doing this example. We'd know it didn't exist if the determinant was 0. Okay, well, we'll come on to that later, but this one, it does exist. Okay, so we're just going to go on ahead and actually do it. So I'm not actually going to take you through all the working for this because it would take quite a while. Suffice us to say, the first thing we need to do is to find the matrix of cofactors. Now, I'll just do a couple of them so you can see what I'm doing. But you would have to do this for each of the elements in the table yourself. So I'll just do it for the 2 and the 2 on the top row, just so you can see how I'm working these out. It's exactly the same as what we did when we found the determinant. So if I do it for the 2, I've only got black and red, so not much colour choice here. I'll start with me red though. So if I do it for the 2 here, so this 2 here, I'm going to find the cofactor of that. So it's cross that out. 4 times 1, which is 4. Take away minus 2 times 1, which is effectively to add 2. So that's going to be 6. But then I have to think about the plus minus matrix and decide whether I need to change the sign of that. Remember, the 6 is a minor, and then you apply the sign change and it becomes a cofactor. As it is, it would have been a plus, so that one stays as a 6. I'll now do the same for this one here. I'll do it in black. I don't know really what that, how that helps, but I'm crossing out this row and this column. So I've got one, this is the determinant I'm doing, so it's 1 times 1, which is 1. Take away minus 2 times 2, which is minus 4. So effectively it's add 4, which gives me 5. However, this would have a minus sign applied to it, according to that weird plus minus matrix that I showed you last lesson. So it's not going to be 5, that's the minor. The cofactor is minus 5. Okay. Now, you have to do that for each of the elements in this table. And I am not going to do that now, because next to me, out of view of you, is my iPad where the notes are, and I'm literally just copying out the answers now. But I'm sure you would know how to find them if you had to do it for yourself. So that is the matrix of cofactors. I'm going to need the determinant for later, so I might as well work it out now. Remember, I don't know if you remember what I said. I'll say it again now to remind you. The inverse is the transpose of the matrix of cofactors multiplied by the reciprocal of the determinant. What a lovely phrase that is to throw into a dinner party or something. Nobody will have a clue what you're talking about. So the determinant then is any row of the originals multiplied by their cofactors all added together. I'll do the top one because it's got a 0 in it. So it's going to be 2 times 6 plus 2 times minus 5. So 2 times 6 plus 2 times minus 5. For completeness, I suppose I should say plus 0 times minus 7. That one obviously doesn't make any difference. So it's 12, take away 10, which is 2. So the determinant is 2. Right, okay, so we've got the determinant, we've got the matrix of cofactors. All we have to do is to remember what Sir said in words. I'll tell you what, let's write it down. Okay, so the inverse is the transpose, we'll come back to that in a minute, of the matrix of cofactors multiplied by the reciprocal of the determinant. What I love about this is it works for other size matrices as well, which is a lovely thing to think about. I'll let you think about that for yourself. I promise you it works though. Right, okay, so transpose of the matrix of this is the matrix of cofactors. Let me just write it out again. Okay, so if I want to transpose that, and that's signified by putting a T there like that, what it means is swap the rows and the columns. So the rows become the columns and the columns become the rows. So this top row here becomes, or first row if you like, becomes the first column, like so. And the second row becomes the second column, and the third row becomes the third column, just like that. And that there is called the transpose of the matrix of cofactors. It actually has a name. This is called the adjoint matrix. I don't know why, but it is. Okay, it's called the adjoint matrix. And so the inverse matrix, I really should have given it a name, so I could have just written m to the minus 1. But I called it m. I wouldn't have had to do this, but I've done it now. So the inverse matrix, that to the power of minus, not to the power of minus, so the inverse matrix, which would be signified like that, will be equal to this matrix here, which is the transpose of the matrix of cofactors, multiplied by the reciprocal of the determinant. So I'm going to write that the other way around. So the reciprocal of the determinant is a half, and then it's just this matrix here. Now you could leave it like that, or if you like, you could multiply each of the elements by a half to actually come up with the final answer. And that is the inverse of that. If you want to check it, I'm not going to do it now. If you want to check it, you would multiply them together and you should get the identity matrix, the one with all the ones down the middle, diagonal, and zeros everywhere else. Okay? That is how you find the inverse of a 3 by 3 matrix. And what I would like you to do now is to go away and try and complete that first exercise that you started last lesson. Now, you can then go on and have a look at exercise 2 and 3. I'm kind of going to make those a little bit optional. If you've got the time, please have a go at them. They are quite good fun, and they do sort of introduce a few new ideas into the mix. But the main thing is to finish that first set of exercises. I've attached the next two to this lesson, though of course you've got it all anyway if you downloaded the zip file, so you can get them all for yourselves anyway, and you've got all the answers as well. Just let me know how you're getting on. The only thing I haven't mentioned, which I perhaps should have mentioned, is what the determinant of a matrix actually is telling you. I should have mentioned this last lesson. The determinant is telling you the volume scale factor if it was a transformation matrix. If it was representing a transformation, then the determinant is telling you the volume. I'm only mentioning that now because you probably need that fact to answer some of the questions on the other exercises. In fact, I think question 4 on the first exercise required you to realise that as well. But of course, if you read the notes, you would know that anyway. So that's it for today. Hopefully that's clear. If not, you can always message me and I'll try and give you a little bit of more information. But please go away and try those questions, and then next time we meet, we'll be moving on to start to look at solving equations, systems of equations using inverse matrices, and also another really cool technique, which well, I'll let you wait with anticipation about what that might actually be. I think I've said everything I need to. Oh, one more thing. I have marked your stats. I'm about to mark your mechanics. I've now got the mark scheme for that for Mr. Price. I will be publishing details on that possibly later today. Okay, and letting you know how that went. I think that's it for me for now. So have fun, and I'll speak to you again soon.